Hello and a very good afternoon, sir. My name is Go Yuxiang, ID 20386. Now today we are going to present for our project video. Now to start it off, let's talk about project A. The circuit consists of four parts: the transformer, the rectifying part, the filtering part, and finally the voltage regulating part. The transformer is responsible for stepping down 240 volt AC voltage to a 220 20 volt AC output. Now, the rectifying part consists of four diodes, which is arranged such that when an AC input is applied to two sides of the rectifier, the opposing two sides will output an DC output. The filtering part consists of a resistor and a capacitor connecting in parallel. And a voltage regulating part consists of two capacitor and an LM7805 voltage regulator, at which when a filtered DC 20 volt is applied at the input, it will output a 5 volt DC voltage. And finally, we'll add an LED at the output to indicate that the circuit works.
Hello, my name is Chua Jia Wei. Student ID is 200000395. I will explain working of Project A. When the input is given a 240 V AC voltage, the high voltage will be stepped down by the transformer to a 20 V AC output. The 20 V AC is passed through a full bridge rectifier and the output will give a 20 V unfiltered DC voltage. The DC voltage is then passed through a filter circuit, where the filter 20 V DC output will be significantly smoothed out. To step down the 20 V DC voltage to a suitable 5 V DC output, a LM7805 voltage regulator with two capacitors on its input and output is used. In the end, the circuit will output a stable 5 V DC voltage where an LED is used to indicate the presence of voltage on the output. Thank you.
Now this is the schematic for project A. As you can see, the transformer, the rectifier, this is the filtering part, this is the voltage regulating part, and last but not least, this is the LED indicator right here. Next, this is the proof that the circuit works. As you can see, I'm probing the output and it shows extremely stable 5 volt output. Now let's continue to project B. The circuit consists of 5 different levels. That is, from level 1 to level 5. There are 5 transistors, each will be responsible for turning on an LED on each level. The resistor is used to limit the current flow across each LED. And lastly, the LED will light up when a pair of designated contact is submerged in water, meaning that if contact signal 1 and level 1 is submerged in water, LED 1 will light up, and then same for signal 2 and LED 2, and that is all for it. This is the physical circuit for it, as you can see, and this is the contact pads right here. As we submerge this, and then we'll see the LED light up one by one. So here's the working for project B. I will pass it to Eugene.
Hello, my name is Eugene Jonathan with student ID 200000452, and I will explain the working of project B. When the circuit is powered with 9 volt supply but is in a dry condition, the circuit acts as an open circuit since no current are flowing into the transistor's gate. When the water level rises towards a pair of contact pads, for example contact pads SIG1 and level 1, eventually the pair of contact will be submerged in water. As water are slightly conductive, the open circuit between S1G1 and level 1 can be visualized as a resistor connecting from the positive power source to the base of the transistor. This will in turn switches on the transistor, allowing current to flow from its collector pin to its emitter pin. This will allow current to flow through the resistor and the LED, thus the LED 1 lights up. When the water level continues to rise towards the pair of contact pads SIG2 and level 2, the same process applies, where the submerged contact pairs will allow current to flow through the gate and turning on the transistor, which in turn switches on the LED. The same principle applies for each level.
Now, lastly, this is the working of project B. As you can see, when the contact pads are submerged into the water, LED 1 lights up, and then when contact pad 2 submerged, LED 2, LED 3, then last LED 4, and last but not least, LED 5 also light up. Alright, next up we have the simulation for project B, which is in Tinkercad. And then we will replace the water with 5 resistors, since water is slightly conductive, so we can replace them as resistor. And also we will put a switch there for each level. So when level 1 is submerged in water, so the LED 1 will light up, level 2, LED 2, level 3, LED 3 light up, level 4, LED 4, and then last but not least, level 5 and LED 5 will light up. Alright, that is all from us. Thank you.